So you've just wrestled a firewall into submission. Now it's standing there, just a big, unintelligent digital wall. Now, the old school playbook says we'd start writing an access control list or ACL, but let's be real. An ACL is just about as modern as a rotary phone. It's just a simple list of rules that says yes or no to traffic. We're not here to be simple. We're here to be smart. Today, we're giving your firewall a brain with security policies. This is how you tell your firewall not just where traffic is going, but who's sending it, what application is it for, and if it's even allowed on your network. Think of it as upgrading your bouncer's guest list from a napkin scribble to a real-time face-scanning database. Let's dive in and make this firewall truly intelligent. All right, so we're here. Let's log back into our firewall. And what we're going to do is get our password right. We're going to open our host inside. And what we're going to do is we're going to start a ping to our host on the outside. So it's 1244.55. And we can see there's no traffic going through. Let's fix that. So in the firewall, in the management console of the firewall, we're going to configure some policies. This is going to be a security policy. So you can see there are some rules there already. There's a couple of hit counts, but traffic still isn't going. We don't want to use the default Palo Alto rules. We want to create our own. So we're going to add a new rule. We're going to name this ping to outside. And our source, this is where we can start to do source any and specific other variations of it. So we're going to pick our source zone as inside. We're going to pick our source address as 10.0.0.0/24. So we're going to take the whole subnet. The destination zone, what zone is this going to go to? We can pick any, or we can specify a zone or zones. So we're going to do outside, and then the destination address is going to be 1244.50/29. So we're restricting exactly who this firewall can talk to. Now, this is where the cool stuff starts to happen. Are we going to look at a specific application ID, or are we going to rely on the old school port and protocol? We want intelligent security rules, so we're going to go to application. And what we're going to do is we're going to look for ping. So we're going to allow ping, and as you can see, there's a ton of other applications that Palo Alto supports. So you can look through here and pick whatever is relevant for you. Service and URL, this is where you would pick the layer 4 port, or if you're looking at a specific URL that you want to block. And then under actions, this is where we can do, what action do we want to do to these packets? Do we want to deny them, drop it, reset it on the client side, so it would be on the inside, reset it on the server side, so it would look like it's coming from the server, or do we want to reset it on both? How do we want to log the sessions? Do we want to forward those logs anywhere? And do we want a specific schedule of when this rule should be active? We're going to just allow. We're going to log at session start and at session end, and we're going to click OK. Now, this by itself isn't going to do anything. Like with anything on a Palo Alto device, we need to commit it. So we're going to come up here, we're going to commit this rule, and we'll be right back as soon as this commit is done. All right, the commit is just about finishing up. Once that hits 100%, we'll close it, and then we'll go back to the server and we'll see if that ping is working. Now, while we're waiting, a reason why this is working from a RFC 1918 address to a publicly routed address is both sides know how to get to the other. You'd want to NAT in a real life situation going from a private IP address to a public IP address. We don't have to worry about that right now in this lab. So as you can see, we already have a hit count going. And if we go back to our host, we can see that that host is now pinging the outside. So here's a question. We now have connectivity from in to out. What would happen if we tried to ping from out to in? Again, you'd want some kind of NAT in a real world environment to do some translations, but because it's the one firewall and it knows about all the different addresses, we don't have to worry about NAT right now. So how would this work? Because that rule's there. What do you think? Let me know in the comments below if you think it's going to work from the outside to the inside. But let's test it. So I want to ping 100.0.0.100. And no, that does not ping. So because there's a rule in place, that does not mean that it's going to allow the traffic to come back in. It's only going to allow anything that's sourced from this network to hit anything that's sourced in this network. And there's actually a connection state table in the firewall, and that's what allows the traffic to pass. So in order to ping from out to in, we need another firewall rule, which is going to be actually the inverse of this guy. So we're going to call this ping to inside from outside. Yes, I know it's a long name for a rule. I'm sorry. The source zone is going to be outside. The source address, you know what we're going to do? We're going to leave it as any. So this is anything that's coming from the source zone of outside. The destination is going to be inside, and we can do the same. We can leave the destination as any, but we're going to configure an actual destination address. Application, same as before. We're going to pick ping. Action, same. Log it, session start, session end. We're going to allow it. Click OK. And then we're going to commit this guy. And then once this commits, I'll come back. And then we'll see if that ping from out to in is now working. I'll see you on the other side of this. All right. We're almost there. So our details is configuration committed successfully. So we should be able to go back here and log back into Eve. Right. Sometimes things happen at the worst times. All right, we're going to have to reopen these guys. So we can see he's still pinging because it was an ongoing job. What about from the outside? All right, we can see the outside is now pinging the inside. Since we turned on logging, we can actually see what this looks like. So we can go to monitor, logs traffic, and you can see we have the traffic, the start and the end of the traffic. So we can search on whatever we want, from source to destination to whatever. So we're just going to randomly pick one of these, and it's telling you what the session ID is, what policy it is, what the UUID, source, destination, exactly where it's coming from. And then it's giving you some more information about exactly what's happening, how many bytes it's transferred between it. So there's a lot of good information that you can get from this particular screen. So let's stop these for a second. And now we're going to forget about the outside for a minute. We're going to slide him over here. And now we're going to go, okay, we want to ping the DMZ. So we want to ping this host that's in the DMZ. Simple rule, right? So we're going to come to our firewall. And we're going to do inside to DMZ ping. Our source is going to be inside, and we're going to do the same thing we've done throughout the entire video. The destination is now going to be DMZ, And our destination address is going to be 172.16.10/25. Application is going to be ping. Now you're probably sitting at home going, wait a minute, we get it's ping, but what about ICMP or traceroute? Is that in the Palo application list? No, let's see. We search for ICMP, that's there too, so we'll add him. And we'll also add traceroute, so we can cover our bases with everything that we can be looking for. Actions allow, and we're going to do the same log at session start and session end. So we're going to commit it. Sorry, we're going to add it. We can see that the rule is there. There's no tags. We have our inside, outside, and the list of applications. So if this rule, excuse me, this rule will hit if any of these applications hit this rule. We're going to, same thing, commit, and then I'll see you once this is committed. All right, and we got it. So let's test. Let's see what happens. So from the inside, let's ping 172.16.100. And it's not pinging. So let's troubleshoot together. Let's see what can be going on here. So our rule looks good from inside 10.0.0.0/24 to the DMZ 172.16.10.25. Let's just make sure we have the interface address right, because we had a problem with that in the beginning. Nope, interface is right. Let's look at our monitor. Let's see what's coming up here. Is it even? Okay. So it looks like it's hitting the rule and it's getting forwarded because we see. So we see it hitting the rule. We see it's hitting the right rule. And it's aging out. Okay. Let's take another look at our policy. Let's just make sure. Policy looks good. And we see it's getting hits. So it looks like the traffic from what this is telling us, so it's hitting it, but the traffic's not coming back from the DMZ. Is there something wrong in the DMZ? Let's take a look. It's not a router. So ifconfig has us at, okay, that's the right address. Let's do route N. Yes, I forgot about this. So the DMZs in this environment aren't configured with a default gateway because you need to enable NAT in order for any host to be able to communicate with the DMZ. This is a interesting security policy, and we're going to look at that in the next video. And just like that, you've successfully taught your digital gatekeeper to think for itself. You didn't just write a list of rules, you created an intelligent security policy that understands user identity and application control. Your firewall is no longer a big dumb brute. It's a finely tuned guardian. The network traffic is flowing, the bad guys are locked out, and your grandma can finally FaceTime without getting a connection failed error. But we did uncover a new issue. We need to figure out how to make the DMZ work without adding a default gateway to any DMZ server. This can be done with network address translation or NAT, and we will look at that in the next video. But remember, this is just the beginning. The internet is a weird and wonderful place, and the next threat is always right around the corner. So stay vigilant, keep those policies tight, and I'll catch you on the next episode of How Not to Break Your Network. Don't forget to smash that subscribe button and let me know in the comments what network shenanigans you want me to get into next. Have a great day.